What we're going to do is add together a certain number of terms of a sequence, but we're not going to use a summation formula here. We're going to use a series formula, which we're going to derive. So you've used these in Algebra 2, but now I'm going to expect you to be able to do the derivation of these formulas and understand where they come from. So we're going to start with this simple sequence that says that a of n equals -2, then 0, then 2. So clearly we're dealing with an arithmetic sequence here. Probably wouldn't be a bad idea to just have the actual formula written out. So since it's arithmetic and the common difference is 2, it's 2 times n minus 1, and our first term is -2. So this is what our formula would look like if I wanted to find a specific term of the sequence. But since this is such an easy sequence, let's just, for a minute, write out these terms and actually see if there's a pattern here that's going to help us understand how to do this a little quicker in the future. So we need 10 terms. They're going to be easy terms to come up with because this is such a simple pattern. All right, and that should be 10 terms. And so what you're going to notice when you add these terms together is that there's a pattern that emerges. If I take the last term, this -2, and I add it with the first term, I get 14. And I'm trying to add them all together, right? So if I add the first and last terms, I get 14. If I add the second and the second to last terms, I also get 14. If I do the same thing with the third and the third to last terms, I get 14. Again, 14. And these are also 14. That's not a coincidence that that happened. That's going to happen anytime you have an arithmetic sequence. Not necessarily that it's going to add to 14, but it will all add to the same number. So now if I want to figure out what the sum here is, it's really not an addition problem for us. It's just a question of how many 14s do I have, and there are 5 of them. So the answer here is 70. So what we want to do is find a fast way and a more general way to arrive at our conclusion when we are adding together the terms of an arithmetic sequence. So let's take a general function and just call it f of n. If I had a general, and we'll say that it's an arithmetic sequence, then our first term would be f1, our second term would be f2, we'd have a third term, and we'd have an nth term, wherever we want to stop at. So the pattern that we've got here is that we're seeing that if I add the first term and the last term I'm looking for, I get the same number as when I add together all those other terms. So in our sequence that we've got here, that would be like taking the first term and adding it to the nth term. And so that's sort of like this 14 that we came up with in our real example. So now the question really just is, where did we get this 5 from, and how can we get that in the future? Well, that 5 isn't a coincidence either, because remember, we were making pairs of terms. So if we take 10 terms and make pairs of them, there are going to be half as many pairs as there are terms, right? Because we're pairing every 2 terms up. So that number there is always going to be half of the number of terms you're trying to add together. In this case, n. So what I'm going to do is multiply this sum here by half of whatever n is, because I'm making pairs of all my terms. And so if I do this, then I end up with a series that is the sum of the first n terms of this arithmetic sequence. And this is a formula that we're going to want to use and you're going to want to memorize, but you should understand where it comes from. It's really just as simple as saying, if it's arithmetic, then by adding up the first and last terms, I'll get the same sum as I do by adding up the next pair in, then the third pair in, and so on. And it doesn't matter how many of these pairs I'm making, these will all add up to being the same number as long as it's arithmetic. So let's apply this formula to a more complicated sequence where we wouldn't be able to just list every single term and see that this is exactly working out this way. So b of n is also clearly an arithmetic sequence. We could just give the formula for it. Looks like the first term is -4, and the common difference would be 5. So this is our formula for this sequence. And I'm asked to calculate the sum of the first 43 terms. So let's use the formula that we just came up with. If I want the sum of the first 43 terms, then that's going to be n over 2 and in this case n is 43. So half of 43 times the first term plus the nth term, which in this case is the 43rd term. All right, so some of this is pretty easy to calculate. I see that the first term is -4, but I don't know the 43rd term yet, so I do have to do a little bit of work to find that. And that's just going to require using this sequence formula that we just came up with, so it's good that we had that. So I want to find b of 43, which just means I need to do -4 plus 5 times 43 minus 1. And when I calculate that, I get 206. So now I know that the 43rd term is 206, and I can throw this into a calculator to calculate the exact answer. But when I add these together and then multiply by half of 43, I get 4,343, which is the sum of the first 43 terms of this sequence. Now I could obviously check that by using a summation like we used before break. We would say that we're counting from the first term to the 43rd term, and we're using this sequence. And we could check, and that should also give you 4,343. So we should still get the same answer, but we do need to be able to do this using our series formulas rather than just relying on summation notation all the time from now into the future.